Welcome to Algebra 2 Trig. Do you have your paper and your pencil? We're spending math in Camelot with Mrs. Bruccolari. All right, so we are starting with lessons. This is Friday's lesson, day 1, and Monday is going to be day 2. So just a little housekeeping before we get to the actual lesson. I want you to remember that I put the homework log up in the Google Classroom. If you haven't opened it, you need to. Ideally, you print it out. You'll have all the homework is there, and until we figure out and fine-tune this new environment of teaching math in Camelot with no students anywhere, just me. Here's King Pellinor. That's all that's here. He's King Pellinor. You are off in the ether. You're going to have to direct yourself, and that means you need to keep track of the homework, but until we get it fleshed out, homework is going to be due every 3 days. So 3 homework every 3 days. So look on that log and you will recognize that there is a due date on Friday, today. So that is, and Friday I'm going to be holding my first live chat, and I think maths time's at 10:30. So if you have questions about Pellinor say hello. Good lady, you've been here too long. I don't want to say hello. I want you to scurry on home. I will, Pellinor, but I got to record this lesson. All right, dear lady. Okay, he's concerned about me. So here we go. Check that homework log. Homework is due every 3 days. How do you submit it? However you do. Take a picture, make it neat and tidy, and submit it under your name. All right, so with that housekeeping, we are now ready to start the lesson. So this is Pellinor. I'm going to put you to the side. He keeps me company and keeps me from... He tries to check my questions and my answers, but sometimes we get running away. So this is day 1, and we're looking at inverses. So a little vocabulary recall information, review on inverses and functions and relations. So a function is where values are used once uniquely. And I remind you that that passes the vertical line test. To create a true inverse, you're also supposed to restrict the domain so it passes the horizontal line test. But title today's chapter is inverse relations. So there's going to be more than one value and actually more than one answer acceptable. And of course, our format of these sinusoidal equations is y equals a times trig b x minus c plus d. So here is my angle, b times x minus c. So that's an angle, and we modify it with vertical dilation, horizontal dilation, left, right, up, down, and that creates my final position. Technically, that's supposed to be the ratio. An inverse, though, is where we interchange x and y. So those are vocabulary words you've seen before. So now we're actually going to do the arithmetic. Remember, video, stop and pause and rewind as you need to. The videos have been so long, they have not been successfully going through Google. So I've had to create a YouTube account to put some of these things up here while Google's catching up with the rest of the universe, the classroom universe, and me included here in Camelot. All right, so my first equation actually comes from the textbook, and it is y equals 12 cosine 3 theta minus 10 minus 1. So you know theta, we're working in degrees. So working in degrees, the first thing I'm going to do, the directions in the book are 3 parts, A, B, and C. Isolate theta to get it alone, and then evaluate theta at a given value of y, and then graph this equation. So the first thing to do to isolate theta is going to be here's the directions. I even wrote them down. Transform the equation to isolate theta, find the value of theta when y is 5, and then graph this puppy. All right, so with that information, we have here my equation. The first thing I do is I get rid of the 1s. How do I undo subtraction? Add 1. Next step is get rid of the 12. Pellinor, how do I undo multiplication? Oh, multiplication. The inverse to multiplication is division, I believe, or as Merlin would tell me. You're right, Kelly. All right, so we're going to divide both sides by 12 with my large vinculum. And now continuing to isolate to get rid of the cosine, I need its inverse. So I take the inverse of both sides to cancel that out and only have the argument. And so there's my inverse cosine of this equals 3 times theta minus 10. Now again, trying to isolate theta, multiply both sides by 1/3. And there's my 1/3, and then add 10. So that's actually part A. So I've transferred the equation. So I can calculate, given any y value, I can actually calculate theta without having to go to a graph. All right, part B, find theta where y is equal to 5. So that's my next step. This is day 1, and so we're only going to find the first positive value of theta. Tomorrow, Monday's lesson, you're going to find the first 3 positive values of theta. And just an aside, reminding you, yes, you're listening. These videos, you can watch them in any order you want, but it's helpful to do them sequentially. So maybe you're going to watch them over the weekend, Saturday and Sunday, to be ready to go. But 3 homework are due tomorrow by Friday at midnight. Or I guess that's today. I'm always, Eleanor, it's like you going forward in time and Merlin going backwards in time. I'm always videotaping on a day that you're not really watching this. Or if you're watching it out of order, you're not watching it. So I don't know. We're all making our way in this crazy Camelot where time and uploads are an issue. So today we're finding first positive value of theta. Tomorrow's lesson is the first 3 positive values. As you read the book, it says such. All right, so here's my theta equation right here. So I just put theta on the left-hand side as customary for unknowns. Now I'm going to put in my y value of 5 and simplify this. So 5 plus 1, last time I checked, is 6. 6 divided by 12 is 1/2. And you go, whoa, Nelly. Yes, whoa, Nelly, this is a famous ratio. You should recognize this. This is not only 1/2, which is famous, but it's positive. So the cosine ratio, you know, is positive in quadrant 1 and quadrant 4, because cosine is like x, so it's positive in both places. 1/2 is the short leg, long leg, so this is 60 degrees here, and negative 60 degrees down here, or coterminal with see, that would be coterminal with 300. Negative 60 is coterminal with 300. So now we're going to have to keep track of all our values. Keep that unit circle somewhere at the ready. So inverse cosine of 1/2 creates an angle, and that angle is 60 degrees, and that's what I'm going to use. So a 1/3 of 60 is 20, and 20 plus 10 is 30. So there is my first value. Ah! I'm off. Pelinor, what are you doing? He's I have so many dust bunnies in the back of my desk. He's over there trying to tidy them up for me. Thank you, Pelinor, but you got to watch me. My paper slid off here. So how far did it slide off? It is way here. All that conversation without anything to watch. So pause the video. Here is putting in the 5. 5 plus 1 is 6. 6 over 12 is 1/2. That's a famous ratio related to 60 degrees. So that entire thing is replaced with 60 degrees. And now I have 1/3 of 60 is 20. Don't forget the 10. And so my first positive angle is 30 degrees. Well, we're learning. I got to keep track of it. Pelinor, you can't stop playing with that. Nope. All right, so now part C is to graph this. Well, graphing is a technique you've learned for a while, and we're reviewing our graphing techniques. So how would I graph this? That's the original equation now. So my original equation, I'm going to take into account A, B, C, and D. And so A is 12, B is 3, B is related to the period. And because it's theta, we're doing 360 divided by 3. So my period is a compression. The whole cycle happens in 120 degrees. And the interval length is 120 divided by the 4 quadrants is 30 degrees. So looking at that, I C, recognizing that value is my start. And since this is negative, I'm going to go positive, which is in the direction of right. So 10 degrees is my start. So 10 plus 30, 40 plus 30, 70 plus 30, 100 plus 30. Here are my 4 tick marks on my cosine wave. All right, then with that information, my D value is going down 1. And here is what my graph is starting to look like. So what happened here? The first thing I did is I drew my horizontal line and I put my values 10, 40, 70, and so on along here. So there's my 10, 40, 70, 100, 130. I also went backwards, although you can't see it. Here's my 10, 0 here. So 10 take away 30 is negative 20. So remember, it's the increment. You have to place the y-axis between this interval length here. 10 to negative 20 is 30. That length is the interval length. And so you get your y-axis placed at the 1/3, 2/3 mark, which is going to be right here. And then space out my amplitude being 12. I know my high value is 12 and my low value is negative 12. Then anticipating the up-down motion, it's only down 1, so 12 down 1 is 11. There's going to be my new maximum. So cosine starts high, so here's the parent graph. I haven't dashed it. Here's the parent top before I go down 1, and then at the next increment right here is the first increment, and here this black point here at negative 12 is the low point before I shift it down at 70. And then at 100, that neutral point, and then up here, the maximum back to 12. Then when I go down from the black dots, everything goes down 1. So this value of 12 drops down 1 to 11. Here at neutral, I drop down on the 40-degree line to here, which is going to be my what is that value? Down, that's negative 1. I didn't label negative 1. Bad girl. So here is negative 1. I think I'll put that in purple. Look, Pellinor gave me these purple pens. Purple's the color of royalty. Isn't he thoughtful? So here is 0 goes down 1. That's that minimum value here. And then we have what? This point here at negative 12 drops down to negative 13, and then 0 drops down to negative 1, going down 1, and then 12 drops down to 11, and then connecting all those points like this. So I have my maximum value here. That is actually not my D value. And this is what the value I'm going to check. So let's hide that. And so that's actually going to be my y, the y value I'm going to check in a little bit. This is y, and my D value is here. This is D, negative 1. The average of the maximum, the minimum, is negative 1. So now here's my graph, part C. All right, and then sketch and verify. So that the y value of 5 that I was talking about, let's move it up a bit so I can see everything. So on part B, we put 5 into the equation and got 30 degrees out. Maybe you need to see that again. So in part B here, we put in 5 up in here and did the math and got 30 degrees. So that's that ordered pair. So just checking that with a straight edge. So here's my y value of 5 and reading over y value 5 to here roughly, and then down. Whoa, it's almost perfect. There it is. There is that reading over and down is about 30 degrees. So it should match both on the graph. Here's algebraically and here's geometrically graphing it. So yay, that all corresponds. All right, so let us try example 2. So example 2, again, is from the textbook, but it's an even one. And I want us to point out that we are going to try to do it on our own. I'll give us a few directions because I had the notes off the video for a bit. So example 2, y equals 8 sine 2 pi over 3 x minus 1 minus 2. Now you know Forrester is picky about this. An x variable, whereas in my first example, theta represents degrees. So here I got a value when I evaluated it at 30 degrees. Here I'm going to do radians. So not only going to pause the video and try to isolate x with a new equation and then solve and then evaluate the graph. You'll have to pause the video, but I'm reminding you when you use your calculator, you have to do it in radian mode, and radians are always given out in 4 decimals, like the ratios and radians are rich at 4 decimal places. All right, so isolate x. You pause the video. Yes, stop. Try to do this by yourself. All right, welcome back. Time warp here. So you isolated x by first, step by step, undoing subtraction of 2, add 2, then undo multiplication of 8 with division of 8, and then undo this entire argument. So that's going to be meaning to get rid of this, I have to take the inverse of both sides. The inverse on that side cancels, and the inverse of this now, inverse sine of y plus 2 over 8 is equal to 2 pi over 3 x minus 1. And then still isolating x, that is my argument. That entire thing there represents the angle. But x is in radians, and we're looking to isolate that completely. So, whoa, that fraction is very interesting. Ours is not to reason y, but to invert and multiply. So 3 goes to the top, and 2 pi goes to the bottom. Write that carefully. 3 to the top, 2 pi to the bottom. And then last step is to add to 1. Did you get that far by yourself? If you did, pat yourself on the back. All right, with that information, part B from the textbook is to find values of x given a specific y value. And today we're only doing 1. Tonight's homework, we're only doing 1. But tomorrow, day 2, we'll find 3 positive values. But today we're only doing 1. So that part says find x in radians, 4 decimals, with your calculator when y is equal to 5. All right, so you're using that equation. Pause the video. Pause. All right, time warp, we're back again. So you plugged in y here and moving this up. So plugging in y, we have 5 plus 2. That is not a famous ratio, 7/8, but it's a good ratio for the inverse sine. Remember, this is a ratio, and this is a leg over hypotenuse, so that's a reasonable value. It's not undefined. So now I have that value. And so let's look at how that looks in your calculator. You put all that into your calculator, and you should have gotten this, 1.5 radians, 1.5 radians. And of course, if we drew that 1.5 radians, we know that that's positive. So it's going to go counterclockwise. Here is 1 radius, and here's a half a radius. It's about right here. So that ratio is positive, and we know the sine ratio is positive in both of these quadrants. So that seems like a reasonable value to get for radians. So there is our value, 1 value. And again, tomorrow we're going to get 3. Then we sketch the original. So here's the original. Now you try to do that by yourself. Pause the video. Okay, we're back with the time warp, and does your graph look like this? How did you do? So I counted for what values? My A value, my B value, which was related to the period, but this is in radians, so you had to use 2 pi. And then here's my C and my D. So 2 pi over 3, my period is normally 2 pi, and this is a horizontal dilation, so it makes an effect. And again, division complex fraction, invert and multiply the fraction on the bottom, so the 2 pi's cancel out. And so I got my period to be 3. And the interval length is that period divided by 4 to account for the 4 quadrants of the unit circle. C is negative here, so I know I go my whole curve. My sine curve is going to go positive right. That's going to be my starting point. And I did change 1 into 4/4, so it matches my interval length, so I can add all those on one step at a time, and then a 2 down. So starting at 1, here's 1, plus 3/4 is 7, plus 3 is 10/4, plus 3 is 13/4, plus 3 is 16/4. Those are going to be my 5 tick marks. But now that I started at 1, I got to place 0 correctly, where the y-axis goes through 0. So 4/4, the value 1, where I'm starting, go backwards on the tick marks, subtract 3/4, I get 1/4. Subtract 3/4 again, I get negative 2/4, or known as negative 1/2. So there was my horizontal line, and 1 is the starting place, adding 3/4, and then going backwards of 3/4 is again how I found the 1/3, 2/3, which is the most common for these high school problems. Placing my y-axis and then drawing my sine wave. So my sine wave starts medium. So medium is at 1, high amplitude 8, down to medium, down to my minimum at -8, up to my medium value, and then I account for the down 2. So this parent graph goes down to my purple. My purple goes down 2. And then this point goes down, and this point goes down, and this point goes down. And then I just connected the curve very smoothly. And then I'm just going to verify at y equals 5, which we already calculated up here. We got 1.5 radians. So at y is 5, remember that's a horizontal line. Y equals 5. So if I draw a horizontal line, I'm going to look for a straight edge. Yikes. Okie dokie. So 1.5 is counting by 2, 4, 6, 8. 1.5. Oh, no, I'm going to y equals 5. Y equals 5 is 4, 6 here, about here. So that's y equals 5. And so the first positive value is here. So if that's 1, that's a little less than 2. So I could say that that's 1.5 if I did my markings a little more clearly. So yay, that verifies. So there you go. Stop and pause the video as often as you need to, and go repeat it, because you're not here. I can't read your body language, and it was our first day at those 3 steps. Isolate x. Find the first positive value of the angle, and then graph it. All right, I will see you on the next lesson video.